For folks who may not have been able to come tonight. So it's great to see some familiar names here on our attendee list. Thanks to everyone for coming on and joining us tonight. So I'm Catherine. I'm with the Chillicothe Public Library, and it is our pleasure to present this program tonight in partnership with the Peoria Riverfront Museum. And our guest presenter tonight is Nick Ray. He's going to be telling us all about meteors, and especially the Geminids meteor shower that is going on right now and peaking on Sunday night. So I'm going to go ahead and turn it over to you, Nick. But before then, if anyone has questions, feel free to drop them in the chat or in the Q&A. Or on Facebook, if you're watching on Facebook, you can drop them in the comments there, and I will do my best to communicate them over to Nick. So we do have one question here, which you may be getting to at some point, but I'll just let you know before we start.
Yeah, give it to me now, anytime.
Why are the meteors in August easier to see? Just because it's warmer? And
it's it just has to do with the actual material, how much material we're going through. This is kind of a unique meteor shower in that it's not from a comet, it's from an asteroid. So that might play a part, but there's a bunch of meteor showers. They're all different because they all come from different sources, and some of them have bigger pieces or smaller pieces or more pieces or fewer pieces. And so each one will be different. But yeah, the one in August is maybe the second biggest after this Geminids one, but more seen because it's August and people can stand to be outside at night looking up at the sky for a while.
All right, so I'm gonna bow out and let you take over, Nick.
Okay, thank you. Yeah, I'm from the Peoria Riverfront Museum and work in the Dome Planetarium where we do star shows, and we're closed right now, but hopefully we'll be open soon in the near future. But yeah, I'll just go through and do a little background on meteors in general. We'll talk about meteor showers and specifically the Geminids meteor shower, which again is going on right now and peaking Sunday night. And then also talk a little bit about the other stuff that's in the sky that you can see if you go outside to look for meteors, because you don't have to, you'll be looking at the sky and there's a whole bunch of cool stuff to look at while you're out there. So let's get started. And if you have any questions during the presentation, I'm happy to try to answer them at any time. So I'm happy to be interrupted. This, by the way, is a painting from back in the 1800s by Frederick Edwin Church, showing an actual historic meteor that was seen back in 1860, which very impressive. It broke into pieces and went across the sky. It inspired a poem by Walt Whitman. So very famous meteor and nice, wonderful painting of it. All right, I'll go from, oops, got my big cursor there so I can point to things. We'll go to a comic strip, classic Peanuts, 1962. Snoopy's on his doghouse looking at the stars, and he's thinking to himself, I am always impressed by the constancy of the stars. It gives me a feeling of security to look up and know that the star I see will always be there and will, and then in the next panel, he sees a falling star or a shooting star, and he lays down with a look of anxiety on his face. So that gets to the main point. Another name for meteors is shooting stars, but they are not stars. Stars are big, hot, glowing balls of plasma, incredibly far away. Meteors are actually made by very small things. I'll show you a picture in a little bit. Very close in the atmosphere. So you see this light up in the sky. It is in the atmosphere. The name meteor kind of goes with that. You might, obviously you're familiar with meteorology or meteorologists who talk about the weather and what's happening in the atmosphere. Meteors are these streaks of light that happen in the atmosphere. And actually back in the old days, for a long time, before about the mid 1800s, people thought that these were just atmospheric phenomena. They did not suspect, or people who did guess that they might be from space were kind of shot down. It was generally thought that these were just things happening in the atmosphere, something like lightning or something like that, making the light go across the sky. So we'll talk a little bit about how people finally figured out that these are objects coming from outer space. But you can see that it's happening in the atmosphere if you look up from the ground or down from outer space. Here's a wonderful perspective from the International Space Station. You can see a meteor from above, which of course only people in space have ever been able to do. A very exotic view. I think that's from the Perseid meteor back, which is the one in August, a more famous one. Here's maybe definitely an even more exotic meteor. This is a meteor on another planet. This is was photographed by NASA's Spirit rover, which landed on Mars back in 2004 and operated, I think, until 2010. Did a bunch of cool stuff, lots of cool discoveries, saw a bunch of cool stuff, including this wonderful black and white picture showing a meteor going through the Martian atmosphere. Very thin atmosphere, but is capable of producing meteors. So the origin of these lights is kind of shocking if you don't know at first, especially compared to the idea of a falling star or shooting star. Microscopic bits of dust. You can see a little, this is, by the way, a photograph taken with an electron microscope. Very small picture. You can see a little scale bar showing the length of 1 micron. And for comparison, the width of a human hair is about 100 microns. So this is significantly smaller than the width of a human hair. So how does a little bit of dust like that in space make that beautiful, bright streak of light that you can see in the sky? It's because it's moving incredibly fast. And different meteors will be moving at different speeds, depending on, which direction the Earth is going and which direction the meteor is coming from. But they can be going 100,000 miles per hour or so. And the Geminids, which we'll be talking about, see how they go 22 miles per second. They're going really fast. They're little tiny, they're going really fast. When they come from the vacuum of space and come through the atmosphere, they are moving so fast, they compress the atmosphere in front of them, press it up really quickly. It heats up the atmosphere very, very fast, hot enough that it actually glows. So you see the streak of light is actually the glowing atmosphere as this super duper fast piece of dust comes in from outer space. And the bigger it is, the brighter the light will be and the longer it'll be able to glow. And in some cases, you'll see what are called fireballs, or technically bolides, which is from the Greek for missile, where you get a fairly significant, bigger than a piece of dust coming through, and you might see just a wonderful streak across the sky that might linger in the sky for a while. In other words, most of the meteors you see are just ephemeral flashes of light, and it's almost like a memory. You just see it and it's already in your memory. Whereas some bigger ones, you'll see the glow lasting for a little bit, which is much more satisfying. And occasionally you get ones that are even big enough to survive without being vaporized. The pieces of dust come in and they're vaporized, and even small pebbles and rocks are vaporized, but the bigger pieces can make it down to the ground. And then we have what's called a meteorite. Here you can see a meteorite out in Sudan with a black fusion crust from the heat as it came in. And that's just a piece of whatever the original rock was. Most of the rock, or at least a lot of the rock, would have been melted and vaporized, and then just some of it in the inside would have made it down to the surface. And just like I showed you that exotic meteor on Mars, here's an actual meteorite discovered on Mars, the first one discovered on Mars by the Opportunity rover. That was NASA's twin rover to the Spirit. They both landed in 2004 on opposite sides of the planet. Opportunity actually lasted all the way up until 2018 and drove something like 27 miles across the surface of Mars, the most distance traveled on another world by anything. And here it is when it drove by its heat shield. You can see its destroyed heat shield, which it had to protect it as it came through the Martian atmosphere. Um, and right next to it, just by chance, you can see a meteorite on Mars. Pretty cool. All right, so meteors, fireballs, meteorites, and meteor showers. When you get a bunch of meteors, not all at once, but much more than usual. And I should mention, just there's meteors going on all the time. You're outside, even when there's like no major meteor shower going on. It's estimated you'd probably see maybe 8 meteors per hour. I shouldn't say that's how many you'd see. That's how many you might be visible if you had perfectly darkly adapted vision, and we're out in a really clear dark sky where there weren't any lights, and you could just see everything. You might see 8 random ones go by. But a meteor shower, you get a significant boost in the number of meteors. And as you can see in this picture, this is a stacked photograph. So many photographs stacked together. So you can see a bunch of meteors, not all coming in at once, but over some period of time. But they look like railroad tracks, which are converging in the distance. And that's because they're all coming from the same direction in outer space, which, as we'll get to later, was the clue that they're actually coming from outer space. When you get a whole bunch of meteors during a meteor shower, call that a meteor storm. This is a wood engraving representing an actual meteor shower, meteor storm. It happened in 1833. It was the Leonid meteors, which happened in November. And it was estimated that about 100,000 meteors per hour were visible during its peak. For comparison, the Geminids, which are going to peak on Sunday night and which are predicted to be the best meteor shower for the year, are going to have maybe 100 meteors per hour at the peak. So this is 1,000 times more than that, and absolutely incredible. So people saw that and talked about it. And this was actually when people discovered meteor showers. So this happened in November of 1833. Well, the following year, people noticed that they didn't see this awesome storm like they did in 1833, but they did see more meteors than you would normally see. And people actually started paying attention all throughout the year, counting meteors, trying to figure out if there were these annual peaks then. After they noticed the Leonids year after year, they started looking for others and gradually found more meteor showers where you'd have this outburst of meteors at the same time every year. So the Leonids were the first meteor shower discovered during this storm in 1833. And a few decades after that, this scientist, Giovanni Schiaparelli, is most famous for his Mars maps that he made. And he's an Italian astronomer. He wrote them in Italian, and he wrote about these channels that you could see on Mars. Mars has a lot of dry riverbeds and so on, but the Italian word was canali, and people mistranslated that in English as not being channels but being canals, and kind of got carried away with their imaginations, imagining a Martian civilization building canals and transporting water to their desert cities. But the origin of that whole craze in the late 1800s, early 1900s was just a mistranslation of the Italian word canali for the channels that people could see. So anyway, his connection to meteors, he made the connection. He was the first one to connect meteor showers, which people had realized then after the 1833 Leonid showers, because they saw that they were all coming from the constellation Leo the Lion. They made the connection that these were coming from outer space. And then eventually Schiaparelli identified the source of the Leonid meteor shower because he found a comet. There's a comet that was discovered a little bit earlier with the same orbits around the sun as these meteors that we'd run into every November. So he identified the Leonid meteor shower every year in November with a comet Tempel-Tuttle, which orbits the sun every 33 years. And there you can see a cartoon of its orbit. Inner planets here, the sun in the middle, Jupiter, Saturn, goes out by the planet Uranus, comes in, well, let me show you the next slide, comes in and actually intersects Earth's orbit. And so what happens what he realized, what happens every year in November, the Earth is in this position in its orbit around the sun, and at that time, it's crossing the orbit of comet Tempel-Tuttle. The comet takes 33 years to go around the sun, so it's not always going to be there, or even anywhere close there. But when we cross its orbit, we cross all of the debris that's been knocked off of the comet by the sun. And in just a minute, we'll look at how comets work and why they are getting debris knocked off of them by the sun. But this was a key connection relating annual meteor showers to comets. And so that was the first one. And then again, gradually more meteor showers like the Perseids were identified with specific comets and their orbits. So here's a lovely photograph of a comet seen from Earth back in 1997, very famous comet, visible for the naked eye for over a year. So you may remember Comet Hale-Bopp. More recently, not as spectacular as Hale-Bopp, but this past summer we had a comet that was briefly visible to the naked eye. Kind of had to get up early in the morning to see it. It wasn't as bright as Hale-Bopp, but maybe you saw it. Comet Neowise. By the way, comets are named after the discoverers. So Comet Hale-Bopp, for example, was discovered by two people, a guy named Hale, a guy named Bopp, at roughly the same time independently. Comet Neowise was discovered by actually a NASA, I don't know if it's NASA, but it's a program that was a NASA satellite actually in space looking for comets and asteroids. So there's Comet Neowise. It's a nice picture through a telescope. And the comet comes from the Latin word for hair. That's because if you go back, it's a fuzzy ball with hair, or something that looks like hair going off of it. These are the comet's tails, and generally a comet will have two tails. You can see one of them here looking blue, the other one white. The blue tail is called the ion tail, and this is from ices in the comet. Comets are generally thought of as dirty snowballs, or you might think of them as icy rocks or icy dirt balls, but the ices, because they come from very far away where it's very cold. Again, this one, the comet responsible for the Leonids comes out from Uranus, which is 300 below zero out there. So the ices are not just frozen water, but frozen carbon dioxide, carbon monoxide, ammonia, methane. And these ices then, when they get close to the sun, vaporize into gases. They get blown away by the sun and actually pushed in the opposite direction of the sun. So this blue ion tail is pointing directly away from the sun. And an ion, by the way, is just basically an electrified gas. So the electrons have been knocked off, and which is why it's able to glow. In this case, the nice blue color. But in the process of the ices vaporizing and getting knocked off of the comet, it also knocks dust loose. The comets have very low gravity, so a little bit of a kick can knock off some dust, and that's what all the white stuff is, what you see in this it's in this curved tail, and that's because the white stuff is too heavy to get, it's dust, it's small, but it's bigger than a gas molecule, and so too heavy to get blown directly back opposite the sun. It's actually that, I should mention, that actually the ion tail gets kind of pushed back by the magnetic field of the sun. So you got a magnetic force field kind of pushing away from the sun as well. But the little bits of dust get spread out because they are small. So they get pushed out by the sun and they get kind of spread out into a broad tail, which can stretch for millions of miles. And as time goes on and the sun continues pushing on it, that stream, that tail gets spread out further and further and further. And so that's what makes up the stream that we run into when we have a meteor shower. There's this broad stream. Again, the Geminids are going on right now, and they're going to peak on Sunday night, but they're going on right now. So we're already passing through the stream, but instead of passing through it in an instant, it takes days or weeks to go through. And you might have, like we'll have on Sunday, a sharp peak when you maybe are in the very center and you're going to have the highest concentration of meteors, of pieces of dust that you're passing through. To mention though that this is a lot of guesswork is involved in this, and so these are predictions of how many meteors you're going to see. You might see more, you might see less. That's just the way it is. All right, so here's an actual comet up close. There have been several comets that have been visited by spacecraft. This is the best spacecraft mission to a comet. This is from ESA, the European Space Agency, basically the European equivalent to NASA. And they sent a mission called Rosetta, which went out to orbit this comet. Don't remember the name, 67P, I think a Russian name, a couple Russian names after that or something. But they orbited this comet for over a year. Got spectacular close-up photographs. I'll share a few of those with you, and even landed a spacecraft on the comet. And we'll look at that too. These comets, and this is general for comets, roughly the size of mountains. There's the comet compared to Mount Fuji. So just imagine it's a mountain floating in space. And that's kind of a nice analogy because mountains have rock, but they also have lots of ice. And again, the comet's dusty and rocky, but also what makes a comet is the ices that vaporize close to the sun. When they got out to the comet, it was not active, and then as it got closer to the sun in its orbit, the ices started to vaporize and jets started to come out, and we got cool pictures like this showing material getting blown off of the comet by the heat of the sun. And there's a cool picture, I think after the fact, showing a pit. So what they found was that there's not ices on the surface of the comet, but coming up, maybe there used to be in the past, they all vaporize, but coming from below as they get heated, eventually they can, you get build up the pressure and the gas can burst through. And so there's this picture here of one of many of these pits where the pressure pushed the gases out and knocked dust loose and stuff like that. Just really exotic landscapes, really weird because the gravity is really weird. As you saw, this comet in particular is a weird shape. Kind of called it like a rubber ducky shape instead of a sphere where everything's pulled down. You get weird stuff. Really cool, awesome landscapes. You want to see more pictures like this? Again, the mission is Rosetta. You can go to the European website for that and spend lots of time seeing awesome photographs. But besides Rosetta, well, Rosetta carried with it a lander, and there you can see it's circled. That's a picture of it, not yet on the surface, but on its way down, descending to the surface. It did get down to the surface, but not the way they planned. When it touched down, it was supposed to fire harpoons into the comet to hold it to the surface because the gravity is so low. The gravity is so low, I didn't check this, but I believe you yourself could just jump off of it and never come back. So very low gravity. They were going to fire harpoons in to hold it into the surface, but for whatever reason, that did not happen. The harpoons didn't fire. It bounced off the surface and ended up bouncing a couple more times and landing much further away. And they had a hard time looking for it, trying to find it. They got radio signals. Eventually, they got pictures where they discovered it. So here's a picture showing a little bit of a leg sticking out from behind some rocks there on the comet. And here's another picture. I gotta move my chat screen around, so you might have to move it. This is over on the right. There's a better picture. You can see a little bit the body of the lander and the leg sticking up because it didn't land the way it just tumbled. It did not land standing upright the way it was supposed to. It did not get to scoop up samples of the comet like it was supposed to, but it got to do other tests as intended. And it was pretty cool. It was like over a year or something before they actually found it and got these pictures back after it landed. And there's kind of a zoomed in picture showing the lander. And this is a picture from the lander. Actually, they got this back initially, from the landing. several pictures. This is kind of the best one. There's its legs sticking up, casting a shadow down. It's the exotic alien terrain. So they got the picture back, and then it's been over a year or so trying to identify where this was on the comet, and eventually got those pictures back showing us. All right, so meteors come from comets. Where do comets come from? Why are they crossing the Earth's orbit? Well, you're probably familiar with the asteroid belt. Most of the asteroids are orbiting between Mars and Jupiter, but there's also asteroids that go all over the place and that cross the Earth's orbit, and we get meteorites. And you may remember a few years back there was one in Russia that exploded in the sky and caused a lot of damage. The shock wave breaking windows. People got a lot of video of it. If you didn't see it, it was the Chelyabinsk meteor. This is pretty awesome, pretty awesome to see. But we don't know if that it was. I think that was an asteroid, but but yeah, there's pieces of asteroids, small asteroids all over the place. That's because most of those asteroids orbiting between Mars and Jupiter are in stable orbits, but some of them aren't. Some of them are in places where over time they'll feel a little bit of an extra pull from Jupiter. Jupiter is the second biggest thing in the solar system after the sun. It's got a lot of gravity. It affects the environment around it. In fact, there's dozens of small moons orbiting Jupiter, which are probably asteroids or even comets that have been captured by Jupiter's gravity. But Jupiter can send those asteroids out of the asteroid belt, and that's why we see asteroids. Just look at the moon, for example. There's craters all over it. We see craters on Mars. There's craters on the Earth. There's a big one out in Arizona, 50,000 years old, a mile across. We have a piece of it, a piece of the meteorite here at the museum. So these asteroids, most of them are in the main asteroid belt, but they get disturbed by Jupiter's gravity, and they can go all over the place. Same thing happens out beyond Neptune. There is another icy asteroid belt called the Kuiper belt. This is out where Pluto is, by the way. And this is where many comets are thought come from. Again, many of the objects out there are in stable orbits, but Neptune is another big gravitational influence out there. And gravity tugs on those objects, and over time it can send some of those things falling in towards the sun, and they can get into unstable orbits, and eventually they can end up crossing the Earth's orbit. So is there a question? I'm ready for a question.
It looks like there is. Yeah. Llewellyn has raised her hand. I'm going to just go ahead and let you talk then, Llewellyn, for a second, so you can ask your question.
I'm sorry, I did not mean to raise my hand.
Oops. Okay, never mind.
No problem.
Sorry about that.
No problem.
Okay, so just as Jupiter disrupts asteroids in the asteroid belt, and that's why asteroids can go all over the place. Same thing in the Kuiper belt. Neptune's gravity disrupts those objects and sends those in, and that's where we think comets come from. Some of them. There's other comets that come in from all over the sky, fly by the sun once and fly out and wouldn't come back for like millions of years. And these are thought to come from an even more distant place in the solar system called the Oort cloud. And the thing that we think whose gravity disrupts those objects to send them falling in are probably nearby stars, stars that happen to pass somewhat close, because this Oort cloud goes out incredibly far from the sun. Let me think, like 1,000 times farther away than Pluto. So you're way out there. The sun's gravity barely holds on to these things. If over the eons, the stars will come and go, and some of them will disrupt those things, and it might take millions of years for them to eventually come into the solar system, zip around the sun, and then fly out, and we never see them again. But so comets come from basically those two main places, or thought to come from, the Kuiper belt and the Oort cloud, and the gravity of other objects, Neptune or passing stars, can cause their orbits to change, and then we get comets that come around. All right, so the Leonids were, again, in November, the first one to be identified with the orbit of a comet Tuttle. And here you can see a list of the most impressive, reliable meteor showers year to year. three of them are highlighted, the Quadrantids, the Perseids, and the Geminids as the three producing the most predicted meteors. You can see the Quadrantids about 25, Perseids 50, and the Geminids 75. At least in this. Actually, I'm not sure when this isn't necessarily this year. I should mention. I just grabbed it because it had a nice list of the meteor showers, and you can see the comets that have been discovered with the same orbits that are responsible for those meteor showers. You can see some are not known yet, and for the Geminids, I don't know if this was left unmarked because it predates the discovery, or because the Geminids are unique in that they're not caused by a comet. They are caused by an asteroid, which is unique. And here's a nice set of radar pictures of asteroid Phaethon, about 3.6 miles across, so a little bit bigger than that comet that Rosetta visited. This, by the way, was taken by shooting the big radio telescope. Let me show you the big radio telescope. Arecibo in Puerto Rico. Among many other awesome science that Arecibo did, it would shoot radar at asteroids or comets as they pass by. And you can see, we didn't even have to send a spacecraft there. That's not a telescopic picture. That's, you can see it rotating and everything. It's pretty cool to do that just with the radio dish, shooting radar, basically like sonar. Same thing with radar. You can get the shape of that object. But you may have heard, if not, sorry to be the bearer of bad news, the dish just collapsed like a week ago, which is really disappointing and is destroyed. So a piece had fallen off a little bit earlier, I don't know, a month or two ago, and they're getting ready to figure out how to maybe dismantle it because it was going to be unsafe. And before they got to dismantling it, the top part, you can see there's when it's observing the universe in radio waves, the light, the invisible radio waves are coming and bouncing off the dish and going up to here to receivers up here. So this is where if you're like, imagine this as an actual telescope, this is where you'd be putting your eye to look. Of course you can't because it's invisible radio waves, but this is where you put the detectors then to detect the radio waves bouncing off of the dish. So these things holding it up failed and it collapsed. And actually, if you go online, there's a incredible video of it. They happen to have a drone up there looking at the wires at the time. Again, they were trying to figure out plans to safely kind of dismantle it after one of the wires fell a month or so ago. And they happened to actually catch with the drone live footage of it, of the actual thing breaking apart and falling down. Too bad. That's been you can see that, by the way, in movies. The movie that comes to my mind is Contact with Jodie Foster, but I think it's in other movies as well. But that's down in Puerto Rico. But anyway, that's where we got this picture of this asteroid, which is responsible for the Geminids, Phaethon, which is named, by the way, after Greek mythology, like a lot of stuff. Named after the son of Helios, the sun god. So the sun god's son. And anyway, the story is he got to drive the chariot of the sun one day and crashed it. So there's a painting of him crashing the sun chariot. And this is selected for this asteroid because it is the biggest asteroid, the only named asteroid, by the way, discovered to the closest one to the sun. So again, most of the asteroids are out in the main asteroid belt between Mars and Jupiter, but there's some that cross Mars's orbit, there's some that cross Earth's orbit, there's some that cross Venus's orbit. This one crosses Mercury's orbit, goes half as close to the sun as Mercury. So it is the closest large asteroid that gets to the sun. I just want to back up here. That's not a picture of Phaethon. This is actually a picture of another asteroid, but I wanted to show you that you can see particles coming off, rocks and dust coming off of this asteroid. And again, the Geminid meteor shower is a result of rocks and dust from the Phaethon asteroid. So it's not ices that are vaporizing and knocking dust loose. It's not actually known how all the rocks and dust and stuff in the Geminid meteors came off of Phaethon. It's possible that some of it is caused by heating from the sun, causing the rocks to crack. And that's actually what's been seen at this asteroid. There's a NASA mission at this asteroid right now. OSIRIS-REx is the name of the spacecraft. The asteroid is named Bennu. You may have seen it in the news just a couple months ago. It actually went down and shot some gas at the asteroid, knocking some of the dust loose and scooping it up. And it's got it stored in a capsule. It'll be leaving that asteroid's orbit in the springtime. Take a couple of years to get back to Earth. I think 2022 in September. It'll fly by Earth, drop the capsule, which will look like a shooting star coming through the sky. And it'll land out in the Utah desert. And then we'll have these pristine pieces of this asteroid to study in our best scientific laboratories. But they were surprised when they got there to see that that the asteroid was active, like an active comet, that there were pieces of the asteroid flying off into space. So that might partly be what happens with Phaethon. It's also thought that maybe there was a big collision, a relatively large asteroid maybe hit Phaethon sometime in the past, which knocked more stuff off than usual, which might be responsible for our best meteor shower of the year, the Geminids. So yeah, there's the orbit of Phaethon, and there is the Earth crossing the orbit of Phaethon every mid-December. And even though the asteroid isn't here, the debris from the asteroid is orbiting the sun, following the same orbit, but spread out because the sun pushes on it a little bit and the gravity of other things pulls on it a little bit, so they get spread out over time. But that's why every December we can reliably expect a bunch of meteors, and pretty sure the peak of the meteor shower this year will be Sunday night around 2 a.m. Sunday night, Monday morning. And they'll be coming apparently from they'll go all over the sky, but they'll be coming from the constellation Gemini, the twins. And you can see here in this drawing how, again, they're going to go all over the sky. You're not going to want to look just at Gemini. You don't need to find Gemini. You just need to look at the sky, as much of the sky as possible. They'll be going all over the sky. But if you trace their paths back, they will appear to point towards a position in Gemini right next to the star Castor, called the Radiant. And that's because they're on basically parallel orbits going around the sun, and they're hitting our atmosphere and parallel, coming in parallel, just like you see parallel sides of a railroad track converging in the distance. Same thing here. You're looking at these converging trails going off into space. And there's again a stacked photograph of a bunch of meteors, Geminid meteors. There's other meteors that'll be going on. There's always random meteors. There's even other meteor showers, small meteor showers. It's basically meteor showers happening all the time. But most of them, some of them might be happening in the day. Most of them might be too faint to even see with the naked eye, but you can detect them with radio telescopes like that one. But yeah, the Geminids is the best one for the most bright meteors going by reliably during the peak. All right, so how can you see this meteor shower? Again, it's going on right now, but it's going to increase until Sunday. So if you happen to be outside and it's clear out, look up, maybe spend some time looking up, and you might have a better chance than usual of seeing a meteor. And if you can find Gemini, you can try to trace it back and see if it is a Geminid or just a random meteor. But for the peak, to maximize your meteor attention, you'll want to go out on Sunday night, so December 13th and the morning of December 14th. They'll be visible all night long, but as Gemini climbs higher and higher in the sky, by 2 a.m. when Gemini is as high as it gets in the sky, that's when you will be able to see the most number of meteors in any direction of the sky. But you can still, there'll be fewer ones early in the evening, but you still have a good chance of seeing a meteor if you go outside in the early evening. So it's nice in that respect. If you don't want to get up in the middle of the night in the winter, maybe just go out before bed and you can catch some, or take your kids out at the school night. So maybe you don't want them up at 2 in the morning, but you can go out before they go to bed and maybe spend 10 minutes and catch a meteor. They'll be visible all night long, but the peak is expected around 2 a.m. So technically Monday morning. And again, about 100 per hour. That's one of the predictions I saw. I saw another one that was 150, another one 75. Could be more, could be less. Just uncertainty, because they're made of these little pieces. It's not like we can actually see these pieces beforehand and actually figure out how many we're going to run into and get. So this is just based on past meteor showers and trying to map out where we are in the meteor stream at what time. And so, but if you want the most meteors, 2 in the morning is your best chance. And again, that's 100 an hour in a very dark sky. So some of them might be too faint to see from your backyard, but if you're out in a really dark sky, they'll be visible. All right, so this is advice you give for every meteor shower. Even the Perseids in August would be dress warm, because the longer you stay out there, the more you lose body heat at night, even in summer. Well, obviously that's a no-brainer. In December, it'll be cold right away. The longer you stay out, the more your eyes adjust to the dark, and obviously the more chance you'll have to see more meteors, and the happier you'll be. Especially if you're going to get up at 2 in the morning, you might as well maximize your time. So try to dress really, really warm, blankets, multiple layers, because you'll just be sitting out there losing heat into the atmosphere. You want to avoid lights to see the most number of meteors. Again, there's going to be more faint meteors than there are bright meteors. So if you want to see more meteors, you want to get into a dark sky, but you also want to let your eyes adjust to the dark. It can take up to about 30 minutes for your eyes to fully adjust to the dark. The most obvious way they adjust is your pupils dilate, but there's also chemical reactions that happen. And so after about 30 minutes of being in the dark, your eyes are as good as they're going to get. But you can ruin that if you're, looking at your cell phone, smartphone every once in a while, or if you're looking at house lights or tree lights or any bright lights. So, even if you're not going out into a dark sky, just in your backyard or something, leave your house lights off. Don't, look at your house lights. Avoid looking at street lights and car lights and stuff like that. And your eyes will adjust, and you'll be able to see a lot fainter stuff than you would otherwise. So avoid looking at lights. Let your eyes stay adjusted to the dark. Look up. Again, you don't want to find Gemini and look at the Gemini twins, because the meteors are going all over the sky. It's fun to trace them back towards Gemini and identify them as Geminids or just sporadic random meteors. But you'll want to be looking to the top of the sky and trying to take in as much of the sky as possible, because they'll be going all over the place. And again, there'll be more faint ones than bright ones. So there will be more ephemeral, brief ones than longer lasting ones. And you just get to see more if you look up and catch as much of the sky as possible. And this is astronomy just for your eyes. You don't want a telescope or binoculars. If you can look through a telescope or look through binoculars. I do that during meteor showers when I don't want to look at meteors and I'm taking a break from the meteors. But if you're looking for meteors, you'll just miss them if you're looking through a telescope or looking through binoculars. So you just want your eyes wide open, dark adapted, looking up to the top of the sky, seeing as much of the sky as possible. Now, if you go out in the early evening, and you do want to go out in the early evening, I'm going to tell you what you should be looking for at 5:30 or 6 o'clock in the evening. But while you'll see fewer of them in the early evening, the ones you do see are likely to be more spectacular, brighter, and longer lasting. And that's because at the angle that you're seeing these would be pieces that don't actually come all the way through the atmosphere or directly down into the atmosphere. They just kind of dip into the outer atmosphere. They kind of graze the edge of the Earth. And so they're not in as dense of a part of the atmosphere. And so they don't fall apart or disintegrate quite so fast. And so you'll see these longer, brighter streaks going across the sky, kind of lower across the sky, Earth grazers. So out in the early evening, again, you're going to see far fewer, but the ones you do see might be more spectacular. But I'll tell you why you want to get out at 6 o'clock to look at the sky. Let me just do a quick circle around the sky at 6 o'clock and show you what's up, and then we'll look specifically at the cool stuff that'll be up all night long that you can see at 6 o'clock, 10 o'clock, 2 o'clock in the morning, or whatever. So this is looking east. You can see this is, by the way, with a free planetarium software, Stellarium. You can download this for free, and you can put your location and what time you want. So I just set it up for Sunday night at 6 o'clock, and this is what it'll look like. We got the Geminids Radiant just coming up at 6 o'clock. You can see there's another meteor shower marked here. I forget how to pronounce that Greek letter. Chi Orionids, Chi Orionids, maybe. But that's a faint one. I don't know if any of those would be visible or not. But like I said, there's meteor showers going on all the time. But the big ones, the Geminids, are the biggest of the year. So this is worth paying attention to and going outside or getting up in the middle of the night for. All right, so 6 o'clock, we've got the Geminids just coming up. We've got the planet Mars up pretty high towards the east, a little to the southeast. And it'll look like a very bright orange star. It'll be brighter than any of the stars. Just want to mention, we talked about Mars rover's Spirit and Opportunity, which saw meteors and meteorites on Mars. There's a new NASA rover headed to Mars. It's in space right now, launched July 30th. It'll land February 18th, and you can watch the landing live streamed on NASA's website, nasa.gov. Now, the live stream is not live footage from Mars. It's live footage from Mission Control at JPL, the Jet Propulsion Laboratory out in California, which built the rover and will be operating the rover. And they'll be showing Mission Control during the 7 minutes of terror, which is what they call the 7 minutes when the rover enters the atmosphere and experiences a blackout and we lose the radio signal. And then hopefully 7 minutes later, it's safely on the surface, transmitting radio signals and letting us know it's on the surface of Mars. But really cool mission. It's going to be looking for possible signs of ancient microscopic life preserved in the rocks of an ancient river delta where a river flowed into a lake on Mars more than 3 billion years ago. It'll be storing samples. It'll be bringing microphones so we can hear what it sounds like on Mars. How is a meteor made? Oh, actually, I should go. Yeah, anyway, so yeah, Perseverance, 2 o'clock, February 18th. Watch that live stream. It also have a helicopter to fly around, by the way. But anyway, we have a question. How is a meteor made? I should mention the whole, the solar system 5 billion years ago was a cloud of dust. The solar system formed. I'll show you actually a cloud of gas and dust that you can see during the meteor shower, a different one, where stars and planets are forming right now. But the sun and the Earth and the other planets formed out of a similar cloud of gas and dust 4.5, 5 billion years ago, collapsed under the force of gravity, rotated just because of angular momentum. Things are moving around and pulled, so spinning around. That's why, by the way, all the planets are orbiting the sun in the same direction today, the same direction that the sun is rotating itself. But they formed out of these pieces of dust that would stick together to make larger pieces and then larger pieces, and you get kind of a snowball effect. You know, you roll a snowball down the hill and it scoops up more snow. You get a bigger pile of dust. Gravity can gradually attract more dust, and eventually you start to get rocks, and they're attracting more rocks. And then, so the solar system was built up from dust and small pieces of rocks, basically from meteoroids, getting bigger and bigger and sticking together. So you can basically think of the asteroids, the meteoroids, the comets as leftover pieces from the formation of the solar system. So pieces like in between Mars and Jupiter, where the gravity of Jupiter kind of affected the material so that it could not coalesce into one large object. or out beyond Neptune, where material, again, could not coalesce because of Neptune's gravity pulling on things, disrupting things from forming into one large object out there. So the meteors basically come from leftover pieces of, or comets and asteroids are basically leftover pieces from the formation of the solar system 4.5 billion years ago. It's pretty cool to think about when you see one of these meteors go across the sky. All right, let's turn now towards the south. Move my chat box over. In the southwest, you can see two planets low and getting lower and setting early. So you can go out earlier at 5:30, or when twilight will be over, and you can see Jupiter and Saturn incredibly close together and getting closer and closer every single night. In fact, they're going to be getting the closest they've been in almost 400 years. Let me get a graphic for that. So they're already close together. They've been close all year. They're getting closer every night. In fact, you should go out every night that's clear, 5:30, 6 o'clock, look to the southwest. Jupiter will be even brighter than Mars. It will look like the brightest star in the sky. Saturn will be fainter than Jupiter, fainter than Mars, still look like a fairly bright star, but they're going to be rapidly converging. And on December 21st, they will be as close as they've been since 1623. So, and in fact, they'll be so close, it's likely that many people will see them as just one object. I don't know. I can't guarantee that they'll look like one object. Might have depend on how good your vision is. Maybe people with really good vision will be able to just see them slightly separated. Maybe most people will see them look like one single object in the sky. They'll be very, very close. You won't want to miss it. Hopefully it's clear out. December 21st, the winter solstice, coincidentally, when Jupiter is going to pass closest to Saturn. But yeah, get out every night you can, 5:30, 6 o'clock before they set, so you can see them low in the southwest getting closer and closer every night. And that's just Jupiter going around the sun faster than Saturn. It catches up to Saturn every 20 years. So it laps Saturn every 20 years. Just happens to be, from our perspective, lapping Saturn closer in the sky than has in 400 years. And just up to the north, a little further to the west, further to the north of Jupiter and Saturn, early in the evening, believe it or not, on the winter in December, you can see the summer triangle, Deneb, Vega, and Altair, three of the brightest stars in the night sky. They'll still be up. You can see them over there in the west, the summer triangle. And of course, in the north, you can only see the Big Dipper, but the Big Dipper is very, very low. So the stars will be fainter because they're looking through more atmosphere. It's likely to be trees or houses in the way, but it's low in the north, pointing up at the North Star. Not the brightest star in the sky, just kind of a moderately bright star, but it's always in the same spot, and the Big Dipper is always pointing. And the moon will not be out, which is good. It's like you want to avoid looking at streetlights and car lights. You want to avoid looking at moonlight, because that'll disrupt your vision. Also, the moonlight, like a streetlight, will make the air lighter, and so you won't be able to see as many dark stars. Or I'm sorry, you won't be able to see as many fainter stars. Again, if you want to make it as good as possible, get away from city lights, get out into a dark park. I like to go out to Jubilee Park, west of Peoria, which is open every night, and you can get a nice dark sky there where you can see the Milky Way, you can see faint meteors. But the darker place you can be, the better. Unfortunately, the moon will not be out, so that will not be making the sky light up, and that's actually because it's new moon. When the moon passes between the Earth and the sun, it'll actually happen December 14th. It'll pass just below the sun from our perspective in North America, but down in South America, from their perspective, the moon will actually go right in front of the sun. They will get to see a solar eclipse. This is a little movie showing the shadow of the moon crossing the Earth on December 14th. So just a small, about half of South America will see a partial solar eclipse, whereas a very small part of South America, just in Chile and Argentina, will see a total solar eclipse. That's the part marked by the dark shadow in the middle, little black dot in the middle. Only those people that are in that path will see the total solar eclipse, like we got to see back in 2017, and we'll get to see again in Southern Illinois in 2024. But no moon, solar eclipse. But you can go online, go to NASA, or just Google solar eclipse in YouTube, and there'll be live streams of that probably from down there in South America if you want to watch it. And speaking of the moon, there is a new robot on the moon, a Chinese robot, Chang'e 5, landed on the moon last week and drilled into the surface of the moon, scooped up samples of the moon, about 5 pounds worth, launched a small vehicle with those samples, which is now orbiting the moon, and will be bringing those back to Earth probably next week, or maybe even before next week. So pretty cool mission, and that's a picture from the robotic lander, which is still there, just a small piece of it launched to bring the samples back to Earth. That's China's third robotic landing on the moon. All right, now the main stuff you can see besides the planets in the early evening, and you can see Mars even later into the night, the winter stuff over there in the direction of Gemini. So you can see this is now 10 o'clock at night. We've got the bright winter stars coming up in the southeast. They'll be up pretty much all night long. You can see there's other meteor showers going on, the Monoceratids, the Sigma Hydrids. Again, those will be really faint to take away the meteors showers. And I want to just show you what's over there in the winter sky, where we have the brightest stars, and you can see some spectacular stuff. So first of all, probably the most recognizable thing in the sky besides the Big Dipper, the belt of Orion, 3 bright stars in a straight line. So you can look for that landmark in the sky. And then surrounding the belt of Orion are 4 bright stars in a rectangle. The 2 above are his shoulders, the 2 below are his legs. So 7 bright stars in the constellation of Orion. One of the brighter ones, distinctly bright orange, it's called Betelgeuse. That's where they got the name for the movie. You can see how they spelled it, Betelgeuse, but the actual star name spelled more like Betelgeuse. And in the movie, they actually spell it the same way as the star name. So that's where they got the name for that movie. A red supergiant. Anytime you see an orange star in the sky, as long as you're not looking at rusty, dusty Mars, you'll be looking at a dying star, a star running low on its nuclear fuel. When that happens, this will happen to the sun in about 5 billion years. It balloons up to a much larger size, cools off, changes color, and looks orange. So anytime you see an orange star in the sky, you will be seeing one of these dying stars running low on nuclear fuel. In the case of Betelgeuse, it's a star that's big enough to explode as a supernova. Probably won't get to see it in our lifetimes. It could explode anytime in the next million years, maybe. But we'll just go across the bright stars on the outside of Orion. There's Bellatrix, which is where J.K. Rowling got the name for Bellatrix Lestrange. A lot of astronomy-related names in the Harry Potter books and movies. A lot of these names, by the way, that's by the way, why that name? Bellatrix is, to mention, Betelgeuse is mistranslated from the Arabic for armpit, the armpit of Orion. Bellatrix is Latin for female warrior. Then Safe, which I think means sword, a reference to Orion's sword. And then Rigel, which means foot. It's the foot of Orion. And it is a blue supergiant. Probably can't see the blue color. A lot of stars have color. You can't see them because they're not bright enough. Your eyes just don't work that way. If they were bright enough, then your eyes could see the color. You can see the color for Betelgeuse and some other dying stars. Here you can see the bright light of Rigel is lighting up a cloud of dust, which is nicknamed the Witch's Head Nebula, which is kind of upside down in this picture, looking at Rigel, 70 light years away. There's a much more spectacular nebula you can actually see with your naked eye. A nebula is just a space cloud. The Orion Nebula is just below Orion's belt in the middle of Orion's sword. Looks like a faint fuzzy star. You'll see it with the naked eye. You can get out your binoculars, look at it. It'll look like a wispy gray cloud. So really cool to look at and to think about what you're looking at. This is the best picture ever taken of it from the Hubble Space Telescope. It's a fluorescent cloud of hydrogen gas glowing a beautiful purple pink color. And there's like 1,000 baby stars inside the nebula. So that's where stars and planets come from, giant clouds of gas and dust. And again, that's where the solar system formed in a different cloud 5 billion years ago. And the meteors are from basically leftover bits of that formation process 4.5 billion years ago. The Orion Nebula. Lots of other clouds in Orion, some of them glowing, some of them reflecting dust, some of them dark. The Orion Nebula is the only one you can see with just the naked eye, but with the telescope you can see all the awesome clouds of Orion. All right, if we follow Orion's belt, we follow it up to the right, and it points at a beautiful star cluster, Pleiades star cluster. It looks like a little itsy bitsy dipper. It's also known as the Seven Sisters. There's a nice telescopic photograph of it. There's a little bit of wispy dust around them. The blue color is because they're hot. Hottest stars are blue, coolest stars are orange. There's the beautiful Pleiades, only 100 million years old. So that's considered young. They formed in a cluster together, in a cloud together, a nebula, and they're still moving through space together. Probably over millions of years, they'll eventually spread apart, but now they're still clustered close together. And by the way, you've heard the Japanese name for the Pleiades, Subaru. That's why their logo is a star cluster. If we follow Orion's belt down, it points to the brightest star in the night sky, Sirius, the dog star. It's the brightest star because it's the closest star you can see at night from Illinois. It's 8.5 light years away, 50 trillion miles away. But that means if you're 8.5 years old, you can look at the star and see light coming from the star that left the star when you were born. It took 8.5 years to get here. You can see a little dinky star next to it. That's actually a dead star. So that used to be a red giant, but it's already run out of its nuclear fuel. It's condensed down to a dead star called a white dwarf. It's about the size of the Earth, but as massive as the sun. That was one of the first dead stars ever discovered over 100 years ago. And Sirius satellite radio got its name and its original logo from the dog star in the constellation of Orion's big hunting dog. Of course, now it's Sirius XM radio. And Sirius Black, another Harry Potter character with an astronomy name. All right, now we're going to follow around Orion really quick, trace out the winter hexagon, this connection of 6 really bright stars. So going from the dog star Sirius, we go up to Procyon, which is Latin for before the dog, because it actually comes up before the dog star. Sirius is Greek for scorching. It's actually the source of the dog days of summer, because it would come up at the same time as the sun in August, and the Greeks mistakenly thought that that's what made it hotter in August, the fact that you had the sun and Sirius out in the daytime. But anyway, so Sirius, and then Procyon, and then up to the Gemini twins, which is where the meteors will appear to be coming from. So the Gemini twins, 2 fairly bright stars, Castor and Pollux. You can see Castor is hotter. It's got that blue color. Pollux is cooler. In fact, it's a dying star on its way to becoming a red giant. So it is running low on nuclear fuel, ballooning up and cooling off and changing color in the process. And there's a nice connected up picture showing the Gemini twins looking like 2 stick figures holding hands. They're named after Greek mythology, twins. One of them, Castor, was mortal, while Pollux was immortal, so twins. And then I think in one of the stories, Zeus put them in the heavens so that they could both be immortal as constellations. We go up to the right of the Gemini twins, we get the bright star Capella, one of the brightest stars in the night sky. In fact, after Sirius, that'll be, and the planets, that'll be the brightest star you can see over there in the winter sky after the summer triangle goes down. Go down to Aldebaran. Aldebaran is the eye of Taurus the bull. It's another dying star, another red giant. You can see the orange color in the sky. And it's in another star cluster, the Hyades. So similar to the Pleiades, but older. But these are about 600 million years old. Again, still relatively young when you keep in perspective that the sun is 5 billion years old. It's a relatively young star still clustered together. And we'll go down from Aldebaran to Rigel, the foot of Orion, and from Rigel back to Sirius. So there's the winter hexagon. You can look for that around Orion and connecting to the Gemini twins during the Geminids. And this is just a wonderful part of the sky to look at. The winter sky gives us the brightest stars, the most interesting things. We saw There's clusters you can see, there's nebulae you can see, there's 3 dying stars you can see, Betelgeuse, Aldebaran, and Pollux. You can see their orange color. There's all these wonderful, more bright stars in this direction than any other direction we look into space. It has nothing to do with the cold weather. It has all to do with the direction we are looking into space. So almost done here. This is a little cartoon showing how we think the Milky Way looks. There's the sun shown on the inner edge of the local arm, which is actually called the Orion Spur. And it's this time of year at night when we look into at night, we are looking into the Orion Spur, our local arm. And it's in the spiral arms where all the action happens. That's where the clouds of gas and dust are. That's where they make new stars, big, massive stars that can run out of fuel fast and explode as supernovas after they become red supergiants. And so we're looking into our spiral arm in the winter, and that's why there's so many wonderful, bright, and interesting things to see in the winter sky over there by the winter hexagon. So hopefully you get a chance to see that sky during the Geminid meteor shower. Of course, it all depends on whether it's cloudy or not. So hopefully it's clear Sunday night. Again, it'll be up all night long. 2 a.m. Monday morning is the peak if you want to see the most. Hopefully at least 100 per hour. But yeah, you can have fun counting and then go online and see how many everybody else saw. And that's it. Let's see if anybody has any questions, either about the meteor shower or about space in general. Anybody has any space questions? And also, if you want to follow the museum, even though we're not open physically right now, we are doing a lot of virtual digital stuff. You can keep up with us on our website, on Facebook, Instagram, Twitter. You can also just follow the planetarium on Facebook or Twitter if you just want the space stuff. Thanks for spacing out with me for a while, and hopefully Sunday night we'll get clear skies and lots of pieces of asteroid Phaethon coming through the atmosphere.
Thank you so much, Nick.
Yeah, my
Does
pleasure.
anyone have questions? Feel free to either raise your hand, your virtual hand, and I'll let you talk, or you can drop a question in the chat or in the Q&A tool. Or if you're watching still on Facebook, feel free to drop a question in the comments there. We'll just keep an eye for a few more seconds in case anything occurs to you. I had to keep on checking that my mic was muted because I just kept saying, wow.
By the way, yeah, thanks for posting all those links along the way. That's
oh, sure.
a nice supplement.
Yeah. Well, thanks for sharing.
What's that?
Thanks for sharing the resources.
Yeah, I noticed I started talking slow and then got faster as I realized that it's taking too long.
All right. Well, it looks like we may not have more questions. So thank you so much, Nick Ray of the Peoria Riverfront Museum. And thank you everyone who joined us tonight.
Yep. Thanks for having me, and yeah, thanks for everybody joining.
And this recording will be up at least for a little while on the library's Facebook and YouTube pages. So if you know of anyone who might want to catch the recording, feel free to share it with them. I'll get that up sometime tonight or tomorrow. So there's still a chance to review bits that you want to go back to or to share it with friends and family. And then best of luck going out to see some of these cool things in the sky.
Yeah, so where's the best place in Chillicothe to go get a quick dark sky?
Oh yeah, anyone have any tips on dark skies near Chillicothe?
I mean, yeah, Jubilee's not that far away, but
Friends with Farms, maybe, or
what's that? Oh, yes, I thought that was the name of a place, Friends with Farms.
That sounds nice. Singing Woods, okay, yeah.
Oh, yeah, if they're open, yeah, I don't know if their gates open or not, that would be.
Mm.
Do they have their gate open? I know I've been there, they have a gate, but is it always open?
Are you about Tawny Oaks?
Oh, okay.
Is that
Yeah,
what you're
Singing Woods, it's like a, yeah, there's like a.
Yeah, I think Tawny Oaks Field Station is there. But I don't know if they have a gate that's always open or not.
Yeah, They have a gate, I know that, and if it's open, then yeah, it'd be an awesome place to go see it.
Mark, do you know if that's open? Do you wanna, if you're still on, you can just drop a comment in there. Okay, maybe not. Okay, don't know. Okay, well, I think with that, we'll go ahead and wrap it up for tonight. Thanks so much again, everyone, and have a good evening.
Thank you.